Hello once more. Yeah, this is Math Simpler. Today we want to talk about something in linear algebra. Our main topic here is linear algebra, but the subtopic we want to talk about today is on eigenvalues and eigenvectors. That's our main topic. So this algebra comprises of many subtopics, from matrices, equations, among others. So eigenvalues, these are just numbers that tells how much something is stretched. Like it's in simple terms, eigenvalues are just they are just scale factors. Like when you increase something by 2, now that 2 becomes an eigenvalue. When you increase the number of children in an orphanage by 2, meaning if they were x and you increase this x to 2x, then this 2 becomes the scale factor. Which is also called eigenvalue. It's as simple as such. Let not these big terms confuse you. Another thing we want to talk about is the eigenvectors. We've already introduced the eigenvalues, and it's just as simple as such. For example, if an eigenvalue, by the way, this sign here is called lambda, and is a Greek alphabet. Is used to denote the eigenvalues. So if we have an eigenvalue to be 3, it means that when eigenvalue is 3, then it means the vector becomes 3 times longer. That's the meaning. It's just a scale factor of 3. Yeah? That's the eigenvalue. Then we have eigenvectors. We have eigenvectors. Eigenvectors are special directions that doesn't change whenever a transformation is applied. Let's take the case of a door. For example, this is a door. And this door, when it is open, it follows this track. And when you force this door to move out of this track, the only thing that will happen to this hinge is either shrinking or becoming long and long. You see? But it will never change the direction. So, the vector of this hinge, let's say it is x1, x2. However much you will try to transform or to rotate this door, this hinge will always remain at the same position. It will never change direction at any moment. It can only shrink or elongate. And the vectors at that point is what we called eigenvector. That's the real time explanation of the eigenvalues and eigenvectors. So we want to go through some word problems and examples on eigenvalues and eigenvectors to help us know how you can get the eigenvalues and eigenvectors from a matrix, because all transformations apply to matrices. For example, the eigenvalues, number one, before we continue, eigenvalues and eigenvectors are only applicable to the square matrices. This is very important. And a square matrix, this is a matrix whose entries in the rows is the same as, whose number of entries in rows is the same as the number of entries in its column. For example, if columns has 2 elements, then the rows, if rows has 2 elements, then columns also has 2 elements. This is a square matrix. So square matrices are 2 by 2 matrices, 3 by 3, up to n by n. These are square matrices. Then from there, we also want to introduce something called an identity matrix. An identity matrix is a matrix of 0 element with one element along its diagonals. An identity matrix is a matrix of 0 element. For example, a 2 by 2 identity matrix denoted as I2. I for identity, 2 for the size, which is equal to 1, 0, 0, 1. This is an identity matrix of a 2 by 2 matrix. I3 for 3 by 3 matrix, we have 1, 0, 0, 0, 1, 0, 0, 0, 1. This is an identity matrix for 3 by 3 matrix. So, when we want to find the eigenvalues of a matrix, let's take an example of a 2 by 2 matrix, which are just letters. we move from general to specific. We first take a matrix whose entries are just in letters. Then we find a way of getting an identity of that matrix, a determinant of that matrix. So we have, let A be our matrix with entries as A, B, C, D. The first thing we are going to do here is to find the determinant, which is, to find the determinant of this matrix, it will be this diagonal, product of this diagonal minus the product of this diagonal, which gives us it is AD minus CB to be equal to that, which is the determinant. So the determinant of a matrix A, B, C, D will be AD minus CB. That's the determinant of that matrix. So for example, we take a matrix of 2, 1, 0, 3. We want to find the determinant of this matrix. It will be 2 by 3 minus 0 by 1, which is equal to 6. So determinant of this matrix is 6. I hope that is captured. In case of any questions, you just type down there. I'll find time to answer. The next thing we are going to talk about is to find the eigenvalues and eigenvectors of a matrix. For example, let's take that our A, B, C, C, D. This matrix, we want to find the eigenvalues and eigenvectors of this matrix. And we will find the determinant of this matrix to be AD minus CB. So for us to get the eigenvalues of this matrix, the first thing we are going to do, the eigenvalues of this matrix, lambda is equal to the determinant of A minus identity of that, the identity matrix with lambda equals to 0. This is the formula for finding the eigenvalues. I know this point gives you some problem. We said that for this is a 2 by 2 matrix, the identity of a 2 by 2 matrix is 1, 0, 0, 1. And here we have our A here, and our A is A, B, no, sorry, A, B, C, D minus lambda, no, sorry, minus I, which is 1, 0, 0, 1, you multiply by lambda. This is the concept This is the substitution of this one here. That's its substitution. We can continue. Because our body is small, we just have to keep on rubbing it like that. I hope you are not going to get lost anywhere. So we said that eigenvalue will be the determinant of A minus that one equals to 0. And our A is A D minus CB. Not really. Sorry. We have our A to be A, B, C, D minus, here we add 1, here we add 0. If you do away with this bracket, it will be lambda 0, 0, lambda. That way, and this one is equal to 0. So, all of this is determinant of all of this will be 0. So, the first thing is to open this curly brace by subtracting this minus this. So here we'll have A minus lambda, B, then C, D minus lambda. This is what we'll get its determinant, then we equate to 0. Yeah. So after that, we shall have something of this nature. A minus lambda, B, and C, D minus lambda. So determinant of this will be equated to 0. So to find the determinant of this will be A minus lambda into D minus lambda, all of this minus CB equals to 0. This is our equation. So when you solve this equation, the value of lambda will be the eigenvalues. So that's how it's done. We can just take an example here to help us understand it even more better. We can just take a good example to help us understand it better. Yeah. Let's take a matrix of 2, 3, 4, 4, 1. For example, let this one be our A. Let that one be our A. So we've said to find an eigenvalue is the determinant of A minus I lambda equals to 0. Meaning we have this 2 minus lambda from our previous discussion. 2 minus lambda, 3, 4, 1 minus lambda, that equals to 0. This one gives us 2 minus lambda by 1 minus lambda minus, all this minus 4 by 3, which is 12, equals to 0. It's just this one, product of this minus the product of this. So here we will obtain a quadratic equation. We are going to get a quadratic equation and this one will be 2 minus, no, let's just do away with this bracket. It will be 2 times 1 is 2. 2 times negative lambda is minus 2 lambda. Minus lambda times 1 is minus lambda. Minus lambda times minus lambda will be plus lambda squared. All that minus 12 equals to 0. Collect like terms. 2 minus 3 lambda plus lambda squared minus 12 equals to 0. The next thing, let us rearrange it in the form of ax squared minus bx plus bx plus c equals to 0. It will be lambda squared minus 3 lambda. This is 2. When it comes here, it will be minus 10 equals to 0. The next thing, yesterday we just tackled our quadratic formula. B squared minus 4ac, all of this all over 2a. That we are going to use that formula to find the value of lambdas. Maths is very easy. Mathematics is very, very easy. When I want to go find the value of lambda, our b is negative 3. Negative by negative, it will be 3 plus or minus negative that one squared, that is negative 3 squared minus 4ac, 4ac, which is minus 10 all over 2. This is 9 minus 10. This one will be 3 plus or minus the root of 9 plus 40 all over 2a. Not 2a. 2 times 1 is 2, which is 3 plus or minus 49. The root of 49 all over 2. Implying that 3 plus or minus 7 over 2, where lambda 1 will be 3 plus 7 over 2 is 5, and lambda 2 will be 3 minus 7 all over 2 is negative 2. So the eigenvalues so we have eigenvalues values of matrix A will be 1 equals to 5, 2, negative 2, and that is the eigenvalues. Now we want to go to the eigenvectors. Now we want to get the eigenvectors. We have eigenvectors getting eigenvectors of that we'll have, it was 2, 3, then 4, 1. That was our A. So eigenvectors here B will be A by lambda really